Now you will at times hear the reference to FOIL, and FOIL is simply an acronym that's supposed to help you remember how to do multiplication of polynomials. The problem is FOIL is only an acronym that works for binomials times binomials, which means you must be working with a two-term by two-term polynomial. So if you think about it in terms of the stacking or the horizontal method or the area model, I'm going to use the area model here for a second. If I use the area model, I would be having two terms, the 7x and the minus 2 along the top or the side, it doesn't matter. And so my length was the 7x minus 2, and my width is the 5x plus 4. And I could go through and I could do each of those multiplications. Here I'd get 35x squared, then I'd get a minus 10x, and then I'd end up with a 28x, and then I'd get a minus 8, and when I combine the like terms, which are those x's, I'd get 35x squared plus 18x minus 8 as my final result from that multiplication. Well, FOIL, like I said, is an acronym or a way to remember how to do this multiplication if you didn't know any of these other things. And what it refers to is first, outside, inside, last. And so it's trying to remind you, whoops, I forgot my inside, didn't I? Hold on. Got ahead of myself. Inside and then last. So it's trying to remind you that if you're going to multiply, since each of the terms in the first have to get multiplied by each of the terms in the second, one way to do this is to say the first things in each set of parentheses will get multiplied together. So we say first, F is my 7x times my 5x, and so that's getting me a 35x squared. That's my first value. And notice that showed up right here in this upper left-hand box. My outside, well, the next thing I would do is I'd take this 7x and multiply it to the other thing. And notice that that is using the numbers that are as far to the outside as possible. And so we refer to that as the outside pair, the 7x times the 4. And so that's my outer pair, that 28x is my outside pair. It does not want to let me to write here. Hold on. So I'm getting a 28x for that outside pair. And that was what I had right here. The next thing I would do then is, since I've exhausted all of my 7x times, now I'm going to do my minus 2 times. And so that would get me the minus 2 times the 5x. And notice those are the two numbers that are as far to the inside of these four numbers as possible. And so when I take the minus 2 times the 5x, I end up with a minus 10x, and that's my inside product, and that's the one that I got right here. And then finally the minus 2 times the 4, that's the last number in each of these sets of parentheses, so that's what they're saying is last, and that's a minus 8, and that's the piece that ended up here. Now, the outside versus inside, it could end up reversed like this, so I had my F.I.O.L. if I went straight across and then went to the next line. It could go F.O.I.L. It doesn't really matter, but essentially the O and the I will be your like terms typically when you're doing these multiplications, and so you end up with a 35x squared plus 18x minus 8, where the 35x squared is your first numbers in each being multiplied, the minus 8 is the last numbers in each being multiplied, but the 18x was the outer pair plus the inner product. And so that actually came from two multiplications that got added together. So it's nice to know what they're referring to when they talk about FOIL, but you don't have to know FOIL as a separate form of multiplication, because as you can see, what I just did here was really the horizontal method of multiplication. And what I did here and got the exact same thing was our area model of multiplication. So they all work the same way.